Okay, so in today's lesson, we're going to have a look at the area of a triangle formula using sine. So it's a simple formula. I've just labeled the parts of the diagram that are relevant. As I discussed with you before I started the recording, visually, you're looking for two legs of a triangle and the angle in between. So the area of a triangle can be given by a half AB sine C. Okay. If you prefer to have the decimal equivalent, you can do, as long as you don't forget that you can use 1/2, a half AB sine C. And that's all there is to it. That's the area formula. So if I know 2 out of 3 pieces of, so there's 4 unknowns here, really, isn't there? There's 1, 2, 3, 4. 4 parts to it. The area itself, A, B, and C. So if I know 3 out of those 4 things, I can work out the 4th thing. So maybe I know the area and I know the angle on one of the sides, then I can work out the unknown side. Maybe I know 2 sides and an angle, then I can work out the area, as long as we have that special relationship of 2 sides and the angle in between. Okay, I'm going to zoom out now so you can sort of see a quick proof. It really is a quick proof, and it's not exhaustive because I'm using an acute angled triangle, and you have to actually come up with another formula for the obtuse angled triangle where the height is outside the triangle. So this is just a quick proof. But you can see here that based upon what I've written here, the area of the triangle, just based upon our primary school, maybe grade 7 or 8 understanding, the area of a triangle is a half times by the base, which is B on this one, multiplied by H. Okay, that's the basic area of a triangle formula, right? And we know that this formula comes from the fact that any triangle is effectively half of a rectangle, So that formula is fairly well established. Well, let's have a look at that triangle. Let's pull out the right angle triangle there, and I'll just color code it so you can sort of see it. There's that part of it there, which is the height, and then we've got, I'm just going to draw it in really roughly here, this part, which is part of the base, but I'm not too interested in knowing what that is, and you'll see why in a second. Plus I've got this part of the triangle, which is length A. So A is now the hypotenuse of this right angle triangle, and the angle C is at the corner of the right angle triangle, like so. So H is the one value that we want to sort of remove. If we can replace H with values that are the other sides of the triangle and the angle C, then we no longer have to work out the height. This is really powerful, right? Because working out the height of a triangle is actually difficult to do unless you're just doing a guesstimate by, putting a ruler down or something like that. Without a compass, without a protractor, without a ruler, just being given a diagram of a triangle, you can't really work out the area because you can't work out the height. So here we go. The relationship is pretty simple. I've got an H here and I've got an A here. I'm going to use this to figure out what H is. So I can see that I've got opposite and I've got hypotenuse. So I know that the sine of C is equal to opposite over hypotenuse. Now, really nice, really quickly, multiply both sides by A. That'll cancel out the A's on the right-hand side. And so we are left with H is equal to A times sine C. Is that okay? Nice and simple, hey? Therefore, the area, which is equal to half base times height, is going to be a half base times A sine C. And then, just because, we're English-speaking human beings, I'm just going to reorder the B and the A because they're just multiplied together, just because it looks more pretty. That's all. BA and AB means the same thing in mathematics. So it's half AB sine C, and that's it. That's the end of the proof. Simple as that. It's not comprehensive because I haven't done obtuse angled triangles, but you could imagine that if I did an obtuse angled triangle, the height is, I'll just do this on the board here, the height would be out here somewhere, but the same relationship would still exist. It'd be, yeah, I won't go any further, but you can do it for yourself if you want to with an obtuse angled triangle, if you want to convince yourself. Any questions? I'm not going to go through an example. Instead, I'm going to provide you with 3 problems. Here they are. Now, with these 3 problems here on the board, what I want you to do is carefully look at the 3 problems. They are graded in order of difficulty from 1 to 3. What I want you to do is read the problem, and if you reckon you can probably do it, move to the next problem. And if you can do that, move to the next problem. And if that means you're ending up with question 3, have a crack at 3. Get completely lost, you can always go back. But I want you to challenge yourself. I want you to think growth mindset rather than just taking the comfort path, and have a crack at something which you think is just beyond your reach. Just beyond your reach. If question 1 at the moment is just beyond your reach, it's legit for you to do question 1. That's why I've got it there. None of them are straightforward. In other words, the most straightforward thing I could do would be to give you 2 sides and an angle and say, find the area. I haven't done that. So all of them have a challenge aspect to them. So don't be like, oh my gosh, I think I can only do 1. Oh no. No, that's still a challenge, right? But I want you to sort of push yourself. One thing I will say though is, so you can see, well, I'll go through each question very quickly, but I need to focus on question 3 for a second. So number 1, you've got a triangle with the 2 legs given, but the angle in between is not, and you know the area, work out the angle. Now, can I say that, oh no, I'll come back and say something in a second. Question 2, what is the side length of an equilateral triangle with area of 3 square centimeters? What is the side length? And question 3, what is the side length of an equilateral triangle such that its area, I'll tell you why I put it in air quotes in a second, is 4 times its length. Now, the reason why I've put it in quotes like that is because area is a 2-dimensional thing, length is 1 dimension. You can't say a 2D thing is 4 times a 1D thing because they're different dimensions. So by that, I really mean so that the number that's the area is 4 times the number that's the length. So like if it was a side length of 1, then the area would be 4. That kind of makes sense? So 3 challenge levels there. There's also another layer of challenge. All 3 of these problems can be done without a calculator. So you can choose to attempt to solve them without a calculator or with a calculator, depending on your comfort level there. No judging, it's up to you to have a crack at that. I'm going to press pause on the record now, and we'll come back in, well, I'll give you a time limit of 5 minutes, but I'll extend it if no one's finished by then, just to finish one of those problems. Here we go. I'm going to go through all 3 problems. I could just give you the answers, of course, but there is something about going through the problem that might allow you to see something which is slightly different to the way you did it. So bear with me, please. So the problem is, problem number 1 is find the missing angle, given 2 side lengths and an area. So personally, I tend to just, because we're new at it, I think I'll just put in the formula to start with, and it's not on the screen anyway. And because I'm a bit of an algebra person, I tend to work in fractions rather than decimals. So I go half AB sine C. So I just chuck it in to start with. Note that I use area, the word area, rather than A, because it might get confused with the angle A. So, making your life as simple as possible by using a few more letters is probably useful. Area equals a half AB sine C. Chuck in the stuff I know, right? So the area is 30. So instead of area, I write 30. A and B is 12 and 10. So I go a half times 12 times 10 times sine C. I'm going to simplify the right-hand side there. So I've got 30 is equal to a half times 12, which is 6, times 10 is 60. Sine C. I'm going to divide both sides by 60 and flip the sides as well because I'd like to read left to right. So I get sine C is equal to a half. Is that okay? If I'm taking too many steps, just say. And then from my prodigious memory, I recall, and not because I just worked it out before class, I recall that the sine of 30 is a half, so C must be 30 degrees. Boom, boom, shake the room. Cool. So that's how you do that one. Question 2 was an equilateral triangle. I didn't mean for this to be so hard, this one. An equilateral triangle whose area was 3 square centimeters. And I had to work out the side length. So I start with drawing a diagram and writing in what I know. I know that these are 60 degrees because it's equilateral. I know these are the same side lengths. So I'm going to call them X. You can call them A if you want. I don't care. That's not the point. The point is I've labeled my unknowns. So step number 1 in solving a problem is to do some construction work for this kind of stuff. So there's my construction work. And now I put it all together. I know that the area of a triangle is given by a half times A times B times the sine of C. I know that A and B are the same thing. They're X. So I've got a half times X squared. And I know that the sine of 60 degrees is equal to root 3 on 2. So that's what I know. Oh, yeah, and the area, which is 3. Cool. I think I meant to make the area 9, and I accidentally made it 3, so it made it a bit harder because of it. Now I'm going to simplify. Personally, what I would do is I wouldn't try and simplify this too much because I think we can move beyond that and say, if I've got a half here and I've got a root, if I've got a fraction here and a fraction here, the sensiblest thing to do when you've got an expression with fractions is just to multiply both sides by the denominators. So if I multiply, I've got a 2 and a 2 here. So if I multiply by 2 and multiply by 2, those 2's cancel out. Okay, so I'm sort of I'm doing this in my head, right? But just to write it explicitly, I'm doing 2 multiplied by 2's here so that I can cancel out. And then I'm just doing the same thing on the other side to keep both sides even. So I end up with 12 is equal to x squared root 3. And I need to isolate the x, don't I? So I'm going to divide both sides. I'm going to flip the sides so the unknown's on the left. But I'm going to divide both sides by root 3. And this, what I see here is a classic example of where rationalizing makes life easier. Okay, so if I rationalize the denominator, that means I'm multiplying top and bottom by the third, by the root 3. And I would do this in one step normally, but I'll just step it out for you. That gives me 12 root 3 on 3, and then the 3 goes into 12 4 times, so I'm left with a simpler construct of 4 root 3. Okay, now if I take the square root of both sides, I get x equaling the square root of 4, 2, and the square root of root 3 is the 4th root of 3. That's the only bit that was a bit beyond what I wanted you to try and tackle, the 4th root of 3. But it's doable. It's just a bit annoying. PS, so why does that work? Well, let's remember our index laws from last year, right? Root 3 equals 3 to the power of a half. The square root of root 3 would be 3 to the power of a half to the power of a half, which is equal to 3 to the power of a quarter because you multiply the powers together, which is the 4th root of 3. There we go. That's just a by the way. So that's a side length, 2 times the 4th root of 3. Now, you know I haven't picked up a calculator yet. Yay me. But if you did pick up a calculator, here's a little something I prepared earlier. Did I? Where's the sheet of paper that I had? Yeah, here we go. It's 2.63, I believe. And again, You should always go to 3 significant figures if you are. Archie, is that what you got when you recalculated?
Yeah.
6.3, cool. It gives me a bit more confidence. Okay, the third problem was an equilateral triangle again. And I'm not going to write down the problem again, but what we were looking for is that the area is 4 times the side length, with the understanding that I'm talking about the numbers and not the dimensions. So again, we need to say, well, what do I know? What's the relationship between them? So I don't know this. Well, I know the angles are 60 because we're told it's equilateral. So this is really just working out the stuff from the problem. I know that it's an equilateral, so all 3 sides are the same. I don't know the side length, so I'm going to give it a side length of x. And I can link the fact that it says area is 4 times the side length to area equals 4x. Okay, so I'm constructing meaning. You're not expected to go, well, yes, clearly the answer is 27.1. Okay, you're not supposed to do that. You're supposed to be like Sherlock and just sleuth it together. Okay. Then if I start with the formula again, because I'm new to it and it's helpful to write the formula down to start with, I then substitute the unknowns and the stuff I do know. So instead of area, I write 4x. Instead of AB, I might just go straight to x squared. Are we okay with that? A and B are the same, so A times B must be the square of x. And I've got the sine of 60, which is root 3 on 2. Cool. So on the right-hand side, I have 2 fractions again. So it's all multiplied together. So this is why I can do it quite handily. I'm just going to multiply by 2 to get rid of the half and multiply 2 to get rid of the over 2 on the root 3 there. And then to keep both sides even, do the same thing on that side. So I end up with 16x is equal to x squared root 3. Okay? Not everyone's looking at the board, so I'm assuming that means that you've surpassed me, so very well done. Now, at this point, you could divide both sides by x. You could. Don't, but you could. The reason why I say you could is because we're dealing with effectively a real-world problem in that triangles exist with side lengths, and therefore we can assume the side length is not 0, and therefore dividing by x is okay. But it's bad practice. It's not good to do it. The better thing to do when you've got squares involved is to get everything onto one side and set it equal to 0. So I'm going to go x squared. If you did this, yay you, because that's what you should have done. X squared root 3 minus 16x is equal to 0. And then I'm going to factorize the x out to get x root 3 minus 16 equals 0. Okay, this is really important, right? Because ultimately, whenever I see a square or a power of 4 or something like that, your gut reaction has to be null factor law. Always, 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 always. Null factor law. And the only way you can use null factor law is to factorize something and have it equal to 0. Okay, always, always, always. So by the null factor law, x equals 0, but it can't. Or x root 3 minus 16 is equal to 0 by the null factor law, right? That's really important for you to acknowledge. In a theoretical state, I guess I could say that if I had a triangle of side length 0, it'd be a dot, which would have no area. So in a sense, but not practical, you could say x equals 0 is kind of legitimate. It's just that you don't get a real triangle out of it. But it matches up though. An area of 0 would have side length 0. Side length 0 would have an area of 0. It does make sense, but it's just not practical. Anyway, moving on to the second solution, which is the practical one. X root 3 equals 16. Add 16 to both sides. X equals 16 on root 3. Divide both sides by root 3. Just to keep it onto this one section here, I'll just finish off, i.e. x equals, and hopefully by now you're starting to rationalize in your head. Root 3 multiply top and bottom by root 3, just moves the root 3 to the top, doesn't it? And you got 3 on the bottom. So 16 root 3 on 3 would be the appropriate answer. No calculator involved. Thank you very much for coming. However, if you did use a calculator, then the answer to 3 significant figures, because this is IB and this is what we do, is 27.7. I hope. I could have just not calculated it properly. Can someone do that on the calculator for me? 16 times root 3. I'm confident with the 16 root 3 over 3 bit. Yeah, can you just recalculate it? I probably made a mistake. 16 times root 3 divided by 3, 9.24. Can someone answer, Sophie? Yes. Remember, Sophie, it is a crutch. You will not have access to that thing at the exam. Just a suggestion, Sophie. Sorry, Jeremy. Cover it. Try it. At least you've got it to flick over, but try it without it. Yeah, I reckon I can finish off the video now, right, though? So that's the 3 questions. And that's pretty much the end.